Good morning, everyone. I'm proceeding with the calculation of question number 33, number 34, 35, and 36. So far, from the various works that I've marked from my students, I've realized that students have got a lot of problems in calculations, especially on the mole. One of the problems is on calculations. A majority of the students cannot be able to do good calculations. So most students need more practice on calculations on the mole, calculations on the enthalpy changes. Another problem which I've realized is the balancing of chemical equations. A student must balance the chemical equation for him or for her to be able to make good calculation of the problems that are there. So since we are at home stretch, we are approaching KCSE, I'm expecting that most students are now having a good mastery of the topics and are now supposed to be doing more practice on specifically calculations on the mole, so that they can be able to solve problems on the mole, solve problems on enthalpy changes in the practicals and also in the theory papers, that is paper 1 and paper 2. Stay tuned. Welcome. We do question number 33 all the way up to question number 36. 4 questions. Question number 33. 10.08 grams of ethane acid H2C2O4.XH2O crystals were dissolved in water and made up to 1 dm cubed. We say that 1 dm cubed is actually 1 liter. So it means our solution of ethane acid has 10.08 grams per liter. 25.0 cubic centimeters of this solution was completely neutralized by 20.0 cubic centimeters of 0.2 molar sodium hydroxide solution. Calculate Roman 1, molarity of the acid, Roman 2, the value of X in ethane acid. Okay, so the first step, we write a balanced equation for the reaction between ethane acid and sodium hydroxide. So we get the products are sodium ethane dioate plus water. Now, ethane acid is the acid, we abbreviate it as A. Sodium hydroxide is the base, we abbreviate it as B. We make sure that the equation is balanced. So the mole ratio, the reacting mole ratio, is 1 mole of ethane dioate reacts with 2 moles of sodium hydroxide. So in the equation must be having the correct chemical symbols. The equation must be having the correct formulas, the correct state symbols, and again, it must be balanced. So this is the reacting mole ratio, 1 to 2. So how do we get the molarity of the acid? The molarity of the acid is obtained by the following equation or the following formula. Molarity of acid, which is our molarity of ethane dioate, times the volume of the acid, that is the volume of ethane dioate, which is 25.0 cubic centimeters. We divide by molarity of the base, which is 0.2 molar, times volume of the base, which is 20 cubic centimeters, should give us the mole ratio of the acid to that of the base. So the mole ratio of the acid is on top, this is 1. The mole ratio of the base is at the bottom, that is 2. So molarity of the acid, we make Ma, the molarity of the acid, subject of the formula, by multiplying by molarity of base, volume of base on both sides, and dividing by volume of acid, and then we get this. Good. So how do you get the molarity of the acid now? So molarity of the acid is equals to 1 times molarity of the base. What's the molarity of the base? 0.2. So this is molarity of the base, that is the 0.2 times 20. What is 20? Volume of the base. So we extract it from here. We take 20, we bring it here, we divide by 2, which was the mole ratio of the base, that is sodium hydroxide. So 2 times volume of the acid. What's the volume of the acid? 25. So you divide by that. So what is the molarity of the acid? The molarity of the acid is equal to 0.08 molar ethane dioate X dot H2O, or hydrated ethane dioate. Roman 2. what is the molarity, the value of X in ethane dioate.XH2O. In other words, the number of moles of water of crystallization. So how do you get that? So molarity is equals to mass in grams per liter, and we say that our mass in grams per liter is 10.08 because 10.08 were present in 1 dm cubed. So the molarity, so the mass in grams per liter is 10.08. Then we make molar mass the subject of our formula. So how do you get the molar mass? Multiply by molar mass, multiply by molar mass, both sides on both sides of the equation. So molar mass is equals to mass in grams per liter we divide by molarity. So molar mass is equals to mass in grams per liter is 10.08. That is the one you have written here. We divide by molarity. Molarity is the answer that you obtained in question in Roman 1 of the question, and we get, should give us, the answer is 126. 10.08 divided by 0.08 should give us 126. So now we equate the formula of ethane dioic acid, which is hydrated, to 126. So how do we get? H2C2O4.XH2O is equals to 126. So 1 is the relative atomic mass of hydrogen times 2, which is the number of atoms of hydrogen. So 1 times 2, we get the mass of hydrogen in ethane dioic acid. We add 12, which is the relative atomic mass of carbon, times 2, which is the number of carbon atoms in the formula. We add again 16, which is the relative atomic mass of oxygen, times 4. This 4 is the number of oxygen atoms in the formula. We add again X. Now this X will affect everything that is present in this water. X times, we put a bigger bracket, into brackets again, 1 relative atomic mass of hydrogen times 2, which is the relative the number of atoms of hydrogen in the formula. We add oxygen, the relative atomic mass is 16, times 1, which is the number of atoms of oxygen which are present. All this should be equated to 126. So when we add all this, we'll have 90 plus 18x should be 126. So 18x is equals to 126. This 90 we take to the other side, we negate or we subtract. So 18x is equals to 36. So we make x the subject of the formula. We divide by 18, we divide by 18. So x is equals to 2. X is equals to 2. So the formula will be H2C2O4 dot, where we had X, we write 2, dot 2H2O. So the value of X is equals to 2. So our compound has 2 moles of water of crystallization. Ambo haina shida. Jonathan, ¿qué pose dan aquí stoppen?
Ka pose.
Es chilo testa. Question number 34. 1.6 grams of magnesium metal is reacted with excess hydrochloric acid. Calculate the volume of hydrogen gas produced. Molar gas volume at STP is equals to 22.4 dm cubed. Magnesium is equals to 24. Step number 1. Write a balanced equation for the reaction between magnesium and hydrochloric acid. So with this the equation, we form magnesium chloride, which is a solution, and hydrogen gas. So the mole ratio is 1 to 1. How do you get the number of moles of magnesium? The number of moles of magnesium is equals to mass of magnesium in grams. We divide by the molar mass. The mass of magnesium is 1.6 and the molar mass of magnesium is 24. So 1.6 is the value that we had here, and this 24 is this value that you have been given here. So mass divided by molar mass. So how many moles of magnesium do we have? 0.06667 moles of magnesium. I've written my answer to 5 decimal places to increase the level of accuracy. So the next step, we show the mole ratio of the reactive mole ratio of magnesium and hydrogen. So 1 mole of magnesium produces 1 mole of hydrogen. So we now ask ourselves, if we know that the number of moles of magnesium are 0.06667, so we'll say if 1 for magnesium is 0.06667, what about 1 for hydrogen? So hydrogen will be 1 times 0.06667, we divide by 1, and the answer will be 0.06667. In other words, the answers are the same, but you must show the working. You cannot assume that since this was 1 and this is 1, then the answer is automatically this. You must show the examiner that you actually obtain how you obtain this answer. Now, we come back and we say we have the molar gas volume. The molar gas volume of hydrogen at STP is 22.4 dm cubed. So we'll say if 1 mole of a gas at STP is 22.4 dm cubed, what about the number of moles of hydrogen that you obtained? Well, that is what about 0.06667 will be how many? dm cubed. So the answer will be 0.06667 times 22.4, and we divide by 1, and we get 1.493 dm cubed. Hey, person. Yeah, by number 35. Tago. Berat taramone. Number 35. 60 liters of sulfuric 4 oxide were made to react with 40 liters of oxygen. Part A, which reactant was in excess and by how much? Part B, what is the volume of the product? Now, the first step, we write a balanced equation for the reaction between sulfur 4 oxide to form and oxygen to form sulfur 6 oxide. So this is the reactive mole ratio. 2 moles of sulfur 4 oxide reacts with 1 mole of oxygen to give us 2 moles of sulfur 6 oxide. So using the Gay-Lussac's law, 2 moles of sulfur 4 oxide reacts with 1 mole of oxygen to give us 2 moles of sulfur 4 oxide. So this 2 is this one. This 1 is the one that is here. So here we have not written anything. It means that this is 1. And here this 2 is this one. So 2 moles to 1 mole to 2 moles. So according to Gay-Lussac's law, when gases react, they do so in volumes that bear a simple whole number ratio to one another and to that of the products if the products are also in gaseous state. So this is that what the Gay-Lussac's law states. That is what the Gay-Lussac's law states. Right? Okay. Now, we now come and say we had 60 liters of sulfur oxide. So if 2 is 60 liters, what about 1? So you'll say 1 times 60 divided by 2, we get 30 liters. What about this one? If 2 is equals to 60, what about 2? So 2 automatically 60 again. So 60 liters of sulfur oxide reacted with 30 liters of oxygen to give us 60 liters of sulfur 6 oxide. So what is in excess? Oxygen is in excess. How do you know that it is in excess? Because it was 40 liters but only 30 liters reacted. So the determinant of this reaction is not oxygen but sulfur 6 oxide. If we had started with 40 here, we would have required times 2, which is 80 on the part of sulfur 6 oxide, and we don't have 80. Instead, we have 60. So the determinant of the reaction is sulfur 6 oxide and not oxygen. So oxygen is in excess by 10 liters, 40 minus 30, which is equals to 10 liters. Part B, what is the volume of the product? So the product is sulfur 6 oxide. So you just come and say, if 2 is equals to 60, if 2 for sulfur 6 oxide is 60, what about 2 for sulfur, sorry, this was sulfur 4 oxide, what about 2 for sulfur 6 oxide? So it will be what? 2 is equals to 60. What about 2? You do cross multiplication, you'll get 60 liters of sulfur 6 oxide. We go to question number 36. During welding of cracked railway lines by thermite, 12.0 grams of oxide of iron is reduced by aluminium to 8.40 grams of iron. Determine the empirical formula of the oxide. Iron is equals to 56, oxygen is equals to 16. Agisuban. Katautag. Paano siya? Agisuban ay asa? Ani kira tasata baru kumanya lulo sa. Manyalu kolo sikotoreton en si tonosi matkoetin matkoib space neo kochobo amatakotien sa. Kasoman questions. So we start by, this is an oxide of iron, so the elements in the oxide of iron are iron and oxygen. Mass, we know that the mass of iron is 8.4 grams. This 8.4 which is here. What about the mass of oxygen? The mass of oxygen will be 12.0 minus 8.4. So here we get 12.0 minus 8.40. So we get what? We get 3.6. Molar mass. The molar mass is actually the relative atomic mass. Iron 56, oxygen 16. Begitu. Kayaknya ya. Mi programnya itu tatar 1 minute gitu. Nhiều trang cái này đâu. Mà vừa lừa tao này cái welcome. Rất là bật tên. Có mấy trái.
Cái nhà của tôi.
Mà tiếc mấy gì?
Này,
Cái xe này, cái xe của Rista cái chỗ. Mana sih saya itu anak itu?
malas maya makses.
Mari lekam makses.
Kaya bayam.
Gaita. Sawa.
Ana nyoru kiyo na la ka. Pi na kararan ko.
Tinde yo tage nyoro. Iba tanay no ate ta.
Kaya lamawin.
Magirta puma na ne. So the molar mass of iron is 56. The molar mass of oxygen is 16. Now the number of moles is obtained by dividing mass and molar mass. So number of moles is equals to mass in grams, we divide by molar mass. So for iron 8.4 divided by 56, we get 0.15. For oxygen 3.16, we divide by 16, we get 0.225. The mole ratio, we find the smallest between 0.15 and 0.225. So the smallest is 0.15. So we divide both by 0.15. So this will be 0.15 divided by 0.15, we get 1. 0.225 divided by 0.15, we get 1.5. Now, the mole ratio is 1 to 1.5. How do we make it a whole number? We multiply by 2. So 1.5 by 2, we get 3. 1 by 2, we get 2. So the empirical formula is Fe2. So iron, number of moles of iron is 2. These 2 here. Oxygen, this is our oxygen. Number of moles of oxygen are 3. So iron has 2 atoms and oxygen has 3 atoms.